Hello guys, welcome back to Network Fate channel. Today we are going to see about VxLAN. So most of the people looking for VxLAN technology. So I have I have done multiple project based on VxLAN background. So here I would like to explain about what is the VxLAN, what are the parameters we are using here, what is the underlay overlay. So today our main focus is looking at the VxLAN. So I tell you what I use that like building the VxLAN data center. So while you building the VxLAN data center, you might need a few parameters. Okay. So first one is underlay, then overlay. These are the concept you might see. You must see on the VxLAN DC build. Yeah, main is underlay overlay and uh, EVPN tunnel. Okay, so underlay, I'm prepared to using OSPF. Overlay, you can use MPBGP. Yeah, EVPN tunnel is kind of overlay. Top on the BGP layer, we can form this EVPN tunnel. So its normal name is NVE, the Network Virtual Ethernet Interface, right? We used to create NVE1. So these are upcoming topics. We can cover it later on. Today we focus on VxLAN. What is VxLAN? So I just drawing out a legacy. Okay. Okay, just as you have connected one of the PC here and another one of the PC here. Let's say this is the host A and this is the host B. Okay. So you know that how Mac had learned, right? Mac will learn flood and learning. Okay. So what it does, right? This is switch 1, switch 2, switch 3, switch 4. Okay. So if host A wants to connect host B, right? So let's assume you are just now you are inserting this cable to switch 1 port, right? So when you're connecting the port, okay, when the port is coming up, it will go for discovery. Okay, discovery means it will start to learn this MAC address and it is learning via which port. This is actually happen. Okay, so people you might see nobody mention about how it is learning. Okay, so this is the actual learning. So when we are connecting RJ45 cable on the switch interface, right? It will go for discovery. So it will when it is discover this host, yeah, obviously you will set some IP address for the PC, right? So it will learn about in the MAC table. Okay, this is the host A MAC address. Port is connected to 1/1, right? So now host A want to communicate to host B. How it will does? It will check this switch 1 MAC table. How to reach my destination MAC of B, right? So it will try to switch 1 try to check the CAN table if I have the detail of destination host B, right? If it is not there, then it will flood. What are the frame it is receiving, right? It will flood all the interface except learning interface, right? You got it. So what are the frame incoming, right? It will learn that it will accept the frame and it will check the own MAC table. If it is not there, then it will go for flood, right? Flood and learning method, right? Now it will it will flood to all the interface, which are what are the interface? For example, it is 24 port switch or 48 port switch. It will send out all the frames send out to all the interface. Now it will going to the this switch, right? So this switch will accept the frame. It will start to listen and it will start to match that MAC address of B. It will check the CAM table, I mean MAC table. So it will check, okay, I have no NT, then it will send out to same way. Okay, it will send out to flood f of 2. F of mean, I mean it is flood to all the content interface except k-mean. So now it will go to switch 3, then it will go to switch 4, then it will go to switch 5. So it will go to the this switch 4. So switch 4, switch 4, if the port is up, right? So it already discovered that host B, okay, it is port number 168, right? Now it will accept the frame, right? I mean, here you will receive the frame, okay? If for switch 4 is already known the host, okay, then it will reply back to the okay, original frame. In case if the switch 4 is not known this host back address, right, then switch 4, it will send it will flood to all content database. For example, in switch 4 we have two PC connected. This is a host B, this is a host C, okay. Even this even the switches learn this MAC of host C, right? Host C connected to port number 1/9, for example, okay. Still it will send the frame to this host C. Why? Because the switch will consider single port. There is a chance I have multiple. There is a chance to learn multiple MAC addresses, right? So switch will consider always, even if I learn the MAC address, so it will send out the frame to that interface, every interface. So now consider switch 4 known this host B, then it will reply back to the switch. It will say like source of my interface is 1/8, and source MAC is B, and destination is 1/7 host A. So why it is it can't keep this interface as a source, right? Otherwise the packet will not transfer throughout the switch. So it have to have the proper port, right? That's why flood and learning will happen, right? So now you understand, yeah. Traditionally, you understand how the flood and learning is happening on the normal Cisco switches, right? So now if you see, because of this much frame is getting over this across all the switches, so what will happen? For example, this is the tunnel, okay. This is the one way, this is the opposite way, and this is the car are going through this way, right? So what happened? Due to the frame, so it is sending out all the interfaces across all the switches. What happened? The incoming traffic is getting high, right? This is the interface, and incoming traffic is getting high, getting into the interface. So eventually what it will does, it will start to utilize whole bandwidth of the interface. So what will happen? For example, it is 100%, right? 100%. It is, for example, this 1 GB interface, for example, it started to keep increasing up to 90%. So what eventually happened, right? As a user, okay, he is trying to access any SAP application or exam any cloud application, he will observe slowness. What the heck, I am unable to browse anything. You might see in your network experience, you might receive those kind of incident, right? So Cisco given one solution to avoid this situation. You can use Strom control. So this is one topic. When you do CCNP, CCI, you will see this concept of Strom control. So Strom control, what purpose is? We can limit the traffic. We can limit how much bandwidth go for broadcast traffic and unicast and multicast. You can do it whatever your preference, right? You know what are the traffic you are observing most of the case. So this is for kind of solution, but it is not actually solving our problem, right? As a network engineer, you want your network have to work very faster than usual, right? So currently, yeah, I would like to inform those details as well. Currently, Cisco is released 9K models. So they are replacing 2960, 36 models, everything. Now they are going to replace with 9200, 9300. So these are the switches is having DNA license, and these switches is much more advanced than this older models, right? So let come back to the VxLAN. So why I explain this Merck learning, because you want to know how it is learning. Obviously you know that, because if you are trying to learn VxLAN, obviously you know that what is VLAN learning and all. So VxLAN, what to uh, overcome this problem, right? The storm control, whatever I'm using, but still it is not effective as much I expected. So for example, this is enterprise, you are going with this solution is okay. Okay, if you are running data center, so you have by default minimum requirement is more than 100 servers. This is the minimum requirement for the running data center, right? Otherwise you won't go for buying the Nexus switches and all, right? So in the VxLAN scenario, what we are doing, right? This is the spine leaf architecture. So this is the spine. It will come like cross connect, right? This is the leaf 1, leaf 2, spine 1, spine 2. Okay. So in this case, this is a example. Here you have multiple servers are connected. Okay. Let's assume storage server, VM, SHAP, something is running on this leaf 1, leaf 2. Okay. Now leaf 1, host V. Okay. If for example this host A want to communicate with the host V, how it is happen on the VxLAN infra, right? So in VxLAN, here till this leaf interface, it will learn like traditionally how it is happening on the legacy way. Same way it will do flood and learning here. Okay. So once this port is learned that host A MAC, right? Host A MAC is AAA, and port is for example 1/1. Then it will check, I want to reach host to V, how I can reach, right? So instead of going for flooding, what we are doing here, we are creating tunnel. Okay. So inside tunnel, the traffic it will go for inside tunnel. The tunnel will start to discover that what are the hosts are connected and the far end, right? So this is the VxLAN. So if you see in the VxLAN, instead of in a legacy way, we used to have trunking, right? Switch to switch, we used to keep trunking. So there is a complication if the engineer using trunk filtering, like allowed VLAN. So there is a chance that the engineer might misconfigure, or for example you already using VLAN 2 to 10 for example, okay, for but you are one of but your Windows team is onboarding new VLAN like 200. Okay. So the engineer have to configure all the devices across your enterprises, right? Or if you are running data center, you have to allow this particular VLAN on this trunk interface, right? So to avoid this kind of scenario, what we are doing here, uh, uh, here there is no additional configuration required like across the switches. So here once you putting new VLAN, right? Already it might have L2 VNI, L3 VNI, those kind of things. I let you know further these things how it will what it will does. But here the VxLAN, okay, uh, first it will go for flood and learning, then leaf will put into the VTAP tunnel. So VTAP tunnel must it will aware if the host V it is connected to VTAP VTAP tunnel 2. So this VTAP to this VTAP, right? VTAP means I'm mentioning it is NVE tunnel, virtual Ethernet in the tunnel. Okay. So this NVE both will exchange their database, like it always in sync. So this VTAP it will aware if I want to reach host V, go to VTEP tunnel 2. So this tunnel, this traffic, it is use this link, either one of the link. It is using ECMP, equal cost multipathing. So first traffic will go like this, and second traffic will go via secondary path. It will take a path like that. So it will use this link to reach the VTEP tunnel 2, and it will go to here. It will check the MAC table div 2. Okay, I am learning this interface 1/10. Then it will, then the packet is delivered to the host V. Okay, previously it will go for flood and learning throughout across all the switches which is connected to the this infrastructure, right? Here it will go, yeah, here also it will go like that way, but instead of going flood and learning for all the switches, it is going via through tunnel. Now we talk about uh, how how the VxLAN. Now you understand what is VxLAN, why we are using VxLAN, right? And yeah, VxLAN, there is a small parameter is there inside, like jump frame, uh, and it is used multicast, like any cast concept. And yeah, underlay already mentioned that OSPF. Overlay you can use MPBGP, and yeah, then VTEP tunnel. So okay, this is the spine leaf architecture. So for connectivity, for reachability, right? So uh, you understand, right, what I'm trying to say here. For reachability, for switch, for leaf one, want to know about spine 1, spine 2, how it will done. It have some it have some reachability, right, like L3 level, because we are using L3 here and L2 is here. In legacy way, we use across L2, right? For example, we are using trunk. So it all are falls under L2, right? L2 traffic. Here we are using L2 and L3. Why we are using? Because we want to stop to flood and learning. It is actually uh, actually hanging up my bandwidth, right? My internal bandwidth. So that's why we are using this solution is making is L2 and L3. So in the L2, it will go for regular flood and learning, as you already said previously. So the form, how we can form VxLAN, right? So the basic concept is underlay. You can run OSPF between leaf spine. Okay, for underlay. So underlay you can using OSPF. Uh, and for best practice, you can make it a leaf all you can use forming neighbor with loopback. For example, underlay you are using loopback 0, then overlay you can use it loopback 1, right? Uh, because there's multiple interfaces connected, right? So you can keep loopback is just point of neighbors. So make it peers with loopback 0 for underlay. So OSP underlay and overlay neighborship you can form with BGP, right? You can form BGP as a overlay. I tell you the command on further slide how we forming that. Just to giving overall figure how we are doing it. So then we are using multicast. Okay, we keep all this spine as the range point. Okay, RP. So the multicast will will help us. Multicast will help us where the devices are connected, what are the no VLAN kind of discovery. It will multicast will help us. So instead of going broadcast, right, flood and learning, we are using multicast to discover the connected device list, right? We are using as a multicast. And finally, we are using VTAP tunnel. Okay, so we are going to use VTAP. I mean, we are going to use NVE interface, and we are putting whatever the traffic, it will go to the NVE tunnel and it will reach back to other. So NVE tunnel always one hop away. Okay, so it will quicker than what it will does on the traditionally. So here there is no flooded lining with this layer, right? This section under spine to under spine to leaf. This area there is no flooded learning. So here everything is unicast, and learning purpose we are using multicast. So I hope you now get some basic idea what is VxLAN, why we are using underlay and overlay, what is the VTAP tunnel, right? So this is all. This is actually pretty easy for initial. It will be a bit complex to understand, but once you realize that what is VLAN, what is VxLAN, what is the drawback is there in VLAN. So to overcome this, we building VxLAN. Like instead of flooded learning, it is going for like we are using L3. Here is everything is L2, right? And other thing is it is for in legacy it will we always see the collision, but in the VxLAN we never seen collision because we are dividing the traffic. We are putting into the tunnel, so the tunnel is already aware what are the hosts are connected to me, right? This VTAP knows what are the hosts are connected to me, what is the MAC address, what is the IP. Every detail the VTAP tunnel already aware, so it easily use some either available path, like by using ECMP. It is equal cost multipathing, so it will take either one of the path and it will send out to the VTAP one, and that VTAP one open the packet and send it to the associated host, right? It is most quicker than traditional way, so that's why we are using VxLAN. Further video I will explain about how VxLAN, what are the commands we are putting to build up the VxLAN and that infra, right? That's all today, and next video I will explain about VxLAN commands and OSPF, MPBGP and VTAP. Try to make it a single video, but yeah, see you soon on next video. Thank you all.